Section 3.5 continued. This will be part B, so hopefully you're going to watch this video as well to continue on with section 3.5. So now we're going to find an indicated function value using function notation. F of x equals 6x minus 2. Again, just think of this as y. So y equals 6x minus 2, and we want to find f of 1. So what does that mean I do? That means the x value is 1, so wherever I see an x, I'm going to plug in a 1. So this would be 6 times 1 minus 2. So 6 times 1 is 6, minus 2 is 4. So I have found f of 1 to be 4. So f of 0. Again, what does that mean? That means x is 0, so I'll plug in a 0. Minus 2 is negative 2. So f of 0 turned out to be negative 2. What about f of negative 1? Again, plugging in a negative 1 wherever I see x. So 6 times negative 1 minus 2, which would be negative 8. So f of negative 1 equals negative 8. Now what is f of t minus 3? What does that mean to do? Well, if x is what is inside parentheses, I have to replace x with t minus 3. So I'm going to get 6 parentheses t minus 3 minus 2. Well, we can do a little bit of simplifying. Distribute the 6, and we get 16 minus 18 minus 2, and that's going to be 6t minus 20. So that says f of t minus 3 is equal to 6t minus 20. Alright, what about 2? Now we're going to talk about radicals. We'll get into radicals later on in the semester, but I wanted to throw in a radical here just to make sure we're okay using maybe our calculator to find out these answers as well. So f of negative 1 means wherever I see x, I plug in a negative 1. So square root of 4 times negative 1 minus 2. Have you noticed that I've been using parentheses when I substitute? Please do so. Don't just plug it in without any type of parentheses. You want to have a parentheses because sometimes you might have to raise it to a power or have multiplication inside and so forth. So make sure you're using parentheses. Well, this turns out to be the square root of negative 6. Well, some of y'all might already know about imaginary numbers, but we're not there yet. So we can't take the square root of negative 6. If you try to put that into your calculator, you're going to get an error because this is not a real number. It's an imaginary number, and we're going to get into imaginary numbers way down and later in the semester. Alright, what about f of negative 1.5? I'm sorry, f of 1.5. So all I need to do is plug in x being a 1.5, so the square root of 4 times 1.5 minus 2. So 4 times 1.5 minus 2 is the square root of 4. And again, if you put that into your calculator, or hopefully you know it, the square root of 4 is just 2. So f of 1.5 is just 2. So what about f of 3? We're going to plug in a 3 wherever we see x. So the square root of 4 times 3 minus 2. So we end up with the square root of 4 times 3 is 12, and 12 minus 2 is 10. We don't really know how to simplify yet, and nothing can come out of the square root of 10 anyway. So f of 3 would be the square root of 10. And now just f of a. So again, wherever we see x, we're going to plug in an a. So it's going to be the square root of 4 times a minus 2, which gives you the square root of 4a minus 2. Now don't take the square root of 4 because you have the subtraction sticking all this together. So there really is nothing we can do to simplify. So we end up with f of a equaling the square root of 4a minus 2. So on number 3, I'm going to do a couple with you, but I'm going to give you the answers for the rest, and I want you to try them and make sure you get them correct. So f of 4 means plug in a 4 wherever we see x, but we see an x in the top and we see an x in the bottom. So we're going to have to plug it into 2 different places. So this is going to be parentheses 4 minus 2 over parentheses 4 squared minus 9. Well, 4 minus 2 is just 2, and we get 4 squared, which is 16, minus 9. And 16 minus 9 is 7. So we have that f of 4 equals 2 7ths. Alright, what about f of negative 1? So I'm going to let you do f of negative 1, and you should have come out with f of negative 1 equals 3 over 8. Positive. So be careful on that one. Let's look at number 3, or part C. F of 3 says plug in a 3 wherever we see x. So we're going to put a 3 there, and a 3 in the denominator. Again, make sure you use parentheses. Well, on the top, 3 minus 2 is just 1. On bottom, we get 9. 3 squared is 9 minus 9. So we get 1 over 0. Can we have 0 in the denominator of a fraction? No. We can have 0 in the top, but we can't have 0 in the denominator. If you put this into your calculator, it's going to give you an error. So what does that mean? That means f of 3 is undefined. We cannot say what it is, so it's undefined. So 0 in the denominator can't happen. 0 in the numerator would just give you 0. So your answer is undefined. And lastly, I'm going to let you do f of a. And f of a is just going to be a minus 2 over a squared minus 9. If you want to factor that, you can, but you don't have to. Alright, so let's go back to number 1. And I want us to see if there's another way to think about f of 1 equaling 4. So this is just a little bit of a thought. Okay, you don't do this, but I just want you to think about this. If I asked you to write that as an ordered pair, could you? Your ordered pairs are x, comma, y. So, how would I write f of 1 equaling 4 as an ordered pair? Well, that's my x, and what comes out is my y. So my ordered pair would be 1, comma, 4. So in this next one, what is my thought that would happen here to give me an ordered pair? Well, the x value is 0, and what comes out was negative 2. So 0, comma, negative 2. Why is that important? Because we want to make connections to things we already have done. And with function notation, you can relate them back to ordered pairs. So the x value negative 1 went in, what came out was negative 8. So negative 1, negative 8. So just something to think about. Function notation actually can be rewritten as ordered pairs. So now let's look at number 4. So if you really understand function notation, and I asked you to graph f of x equaling 4x minus 1, you should be able to, because we truly have already graphed these things. So how would I graph f of x equaling to 4x minus 1? Well, what did I say f of x really was? F of x was really just y. And you should be able to graph y equaling 4x minus 1 because we've just done those. So this is in the form of y equals mx plus b. Or you could make a table. Or you could do the intercept method. So b is negative 1. And my slope is 4, which tells me to go up 4 and to the right 1. Or you could go down 4 to the left 1. And there is f of x equaling 4x minus 1. So again, I just want you to realize f of x just represents y. So you can put it in y equals mx plus b and graph it that way.